Okay, take two. Here we go. I'm going to go a little bit faster probably than compared to the original video, only because a lot of this I talked through with you in class. I will demonstrate a few ideas. I suggest then hitting pause before you go into the following similar examples. Give yourself a chance to process through it before you move on, and then go ahead and hit unpause, and then I will go ahead and talk through how to work through some of these scenarios. We talked in class about the square root of negative 18 is no longer going to be expressed as a value that does not exist. Instead, we're going to go ahead and split up these ideas into, or split up this radical into negative 1 times 18, with the idea being that I can then split up this singular radical into two radicals being multiplied together. We know from Wednesday that this square root of negative 1 is I, and therefore I essentially do what we're going to refer to as take the I out. And then from geometry and algebra, we then go ahead and reduce that radical square root of 18. We pull, just as a reminder, square root of 18 comes from square root of 9 times 2. This square root of 9 becomes 3 root 2. This gets simplified to 3I root 2. Now we're going to write any type of square root of a negative in such a way. So square root of negative 12, for instance, is going to be the square root of negative 1 times 12. I'm going to split this up. And like we just talked about, this square root of negative 1 will become I. This square root of 12 reduces by pulling a 4 out as a 2. This is 2 root 3. And then we're going to get in the habit of putting the coefficient in front of the I like that. Go ahead and hit pause and try B and C. Here we go. This is the square root of negative 1 times 25. This is the square root of negative 1 times the square root of 25. This is I times 5. We're going to write that as 5I. And the square root of negative 7 is going to be the square root of negative 1 times 7. You can go ahead and start to jump to this answer as you start to see and understand this better. This is going to be an I root 7. Because this is not reducible, root 7 has no perfect square in it, we go ahead and leave it like that. Now, as you go to take your group quiz on Monday, you're going to need to be able to do an idea like this. If I go to multiply square root of negative 4 times, let's say, the square root of negative 12, what many people are going to try to do is say, oh, I can go ahead and combine those through multiplication and say, oh, well, this just must be the square root of 48. And since it's the square root of 48, there's a 16 in there, this answer must be 4 root 3. But here is the problem. This does not work that way. Why? Because the rules of negative radicals is not the same. You must always, start this and write this please, always take I's out first. Always. So this right here is 2I. This right here, we know from above, is 2I root 3. Now notice, it is still a 4 and a root 3, but this is now I squared. And therefore, that we know from experience that this I squared is negative 1. This answer is negative 4 root 3. Now, we talked quickly about the definition of what we have here. We are getting used to using what's referred to as complex numbers. We talked in class about how complex numbers come in the form A plus BI. A is the real part, B is the imaginary part. And if I have these two pieces together, both a real and an imaginary, meaning B does not equal 0, I have an imaginary number. If A is 0, I have 0 plus BI. Essentially, there is no real part. And in that case, we have what's referred to as a pure imaginary number, meaning pure by itself, no real part. I encourage you to pause long enough to look at this actual definition. As a quick reminder, when I look at these real numbers, the real numbers that I'm used to is the actual structure of natural numbers, inside whole numbers, inside integers, inside rational, and the combination of these four, along with irrational, make up real numbers. But now as we add on the imaginary number option, it's the combination of these that make up all complex numbers. So on this slide, if you would, hit pause and label these according to whether or not they are real imaginary or pure imaginary. Okay, we should have listed the real, which are just of the form A only plus 0B. We've got a real one here, 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 and here. This is irrational, but it is still real and no imaginary part. It's pure imaginary. We just talked about if it's 0 plus bi. So I have a pure imaginary here and here. And when I have both a real and imaginary part, I have an imaginary number. So I have an imaginary number here and here. We have talked already about how to graph these complex numbers in a complex number plane. So I'm just going to briefly remind you that in the number negative 5 plus 3i, a is negative 5, b is 3. So when I go to plot that, I go 1, 2, 3, 4, 5 over along what is referred to as the real axis. This here is the real axis. I go 1, 2, 3, 4, 5, up 1, 2, 3 along the imaginary axis. This is A. Go ahead and hit pause, and if you haven't already, do B, C, D, and E. Here we go. This real part is 0. Our imaginary part is 6. This is the ordered pair, 0, 6. 1, 2, 3, 4, 5, and 6. There's B. For 5 minus I, my real part is 5. My imaginary part is negative 1. 1, 2, 3, 4, 5, negative 1. That is C. For D, my real is negative 3. My imaginary is negative 2. 1, 2, 3, 1, 2. And for E, we got the hang of this now, hopefully. A is 1 and B is 4. Over 1, up 1, 2, 3, and 4. That is point E. We then go on to add and subtract. So I'll just remind you, and we'll emphasize this more even next week. This adding and subtracting, these operations on imaginary numbers, allow me to combine real parts and imaginary parts. So 3 here and 2 here are the real parts that go together. 4i and 5i are the real parts that go together. When I subtract, the same rules of variables apply in that I distribute this negative here and here. So I have here 5 plus 2 is 7. Negative 3i minus 4i is minus 7i. Do me a favor, go ahead and hit pause and come back once you finish not only this slide, but if you would for me, if you get the hang of this, go ahead and do these 4 as well. Okay, so I'm going to go real quick through this. My answer here will be 4 minus 8i. Notice every single time I'm putting my answer in the form a plus bi. That is considered standard form, and that is going to be how the anal retentive side of me is going to ask you to present these solutions. This is 1 plus 5i minus 3 plus 2i. This is negative 2 plus 7i. We talked briefly about a couple of these. My answer here to number 7 is 7 plus 3i. My answer here in number 8 is negative 4 plus 9i. My answer here in number 9 is 6. Notice that just has a real part. Why? Because this is negative 5 and this is plus 5i. Again, don't hesitate to write out the steps if you need to. Even on number 10, I prefer to. This is 6 plus 2 minus 9i plus negative 8 plus 4i. This distributes here and here. So I have plus 2 minus 9i. I can put the 6, the 2 together, that's 8. 8 minus 8 is 0. So that real part is gone, leaving me with a pure imaginary number, negative 5i. As we move on, these two we went over in class, or at least number 11 we went over in class. A quick reminder, when I move on to multiplication, this is 3i times 1 minus 3i times 4i. Keeping in mind that this is just simple combining like I do variables until here, because now with I squared, I have to worry about the fact that I squared has a numerical value. This is 3i plus 12, and when I give the final answer, it is 12 plus 3i. Do me a favor and go ahead and hit pause and try to do 12, 13, and 14. Here we go. This is going to be a distribution as well. Sometimes we reference it as FOIL. This is going to be 5 plus 2i plus 15i plus 6i squared. Just for one more time of seeing the whole thing, this is going to be a plus 17i. This is going to be 5. And notice I'm going to go plus 6, this I squared is going to be replaced with negative 1. 5 minus 6 is negative 1 plus 17i. Negative 1 plus 17i. We're going to move on to number 13, being very careful not to distribute that 2. It does not distribute. Instead, 4 plus 3i is multiplied by itself. Notice this looks a lot like a perfect square trinomial factored form. This gives me 16. Outside is 12i. Inside is 12i. That's plus 24i. And then the last is plus 9i squared. But this is really negative 9. Notice I went a little faster that time. This is 7 plus 24i. And in number 14, you have a special case. Notice this should look like the factored form of the difference of two squares. This gives me 64. Outside gives me 24i. Inside gives me 24i. What's notable is those cancel. Minus 9i squared. But we now know that this is plus 9. 64 plus 9 is 73. Notice that that is a real part only. Therefore, the imaginary part is gone. So that becomes significant when we move on to division. And I pointed this out just quickly in class. When I multiply out these two expressions that again look like the factored form of the difference of squares, this gives me 1. Outside is plus 2i. Inside is reverse. Outside is minus 2i. Inside is plus 2i. Then minus 4i squared. When I have two expressions, notice that the real parts are the same, but the imaginary parts are their opposites. Every time that happens, I get a real number only. The reason is these are referred to as complex conjugates. And the product of complex conjugates is always real because the imaginary part cancels. The reason that is especially helpful is when I go to divide, because my end goal of any operation of imaginary numbers is to get into a plus bi form. Notice this is definitely not a plus bi form. So I need to multiply by something equivalent to 1. It is the only algebraic step that I can take that is legal. So in order to be equivalent to 1, it's going to be the same on top and bottom, but I want to get rid of the i's on bottom. So to do so, I multiply by the complex conjugate. Notice the real part stays the same. The imaginary part is its opposite. If I put it on bottom, we're just going to play out the bottom for a minute. The bottom only is going to be distributed out so that I have 1 outside, inside will give me minus 2i plus 2i. That's gone. Then it's minus 4i squared. So this bottom only becomes 5. On top, I then have to put the same expression so that this entire fraction is equivalent to 1. This then distributes. I have negative 3, then plus 6i, minus 11i, plus 22i squared. We now know this is minus 22. This gives me negative 25 minus 5i. This is not okay to leave it like this because it does not look like a plus bi form, and so I turn this into negative 5 minus I. Negative 5 minus I. Now there's a small exception to how this can work in letter B, but the rules are still the same, and if you want to flat out stick to the rules, you always can. The rules are that I need the i's out of the denominator. I need to multiply by something equivalent to 1. And I need the imaginary part to be the opposite. Now, if you're like, hey, couldn't I just do 4i because actually just positive 4i would work in this case? The answer is yes. But to be consistent with the rule about a complex conjugate, it is the imaginary part that becomes the opposite. So this allows me to keep the rule intact if you thought of this as 0 plus and 0 minus. On bottom I have, I'm going to take that red off just so you don't get confused. On bottom I have negative 16i squared, and on top I have 20i plus 12i squared. We know now this becomes negative 12. This is, and on bottom I have positive 16. So on top I have negative 12 plus 20i, and on bottom I have positive 16. This still is not done. I have to be in the habit of reducing this so that this is in a plus bi form. So my final statement is to reduce negative 12/16. If I divide that by 4 and divide this by 4, I have negative 3/4 plus 5/4 I. Negative 3/4 plus 5/4 I. Go ahead and hit pause if you would. And go ahead and do numbers 1 and 2. Here we go. I'm going to go ahead and do this one first. And just to prove the point, you could actually multiply by just the exact same thing, since it's just the imaginary part and it's pure. I have 25I squared, and we know that that's going to become negative 25. Sorry about that. And on top, I have 10I plus 5I squared. Let's try that again. Sorry. 10I plus 5I squared. We know this is negative 5. This is negative 5 plus 10I. Hopefully you're getting decent at this enough to know it is not okay to leave it like that. This gives me 1/5 plus divide by 5, divide by 5, that's negative. Remember, that's what's left over. So this is really 1/5 minus 2/5 I. In the long run, whether you did 5I or negative 5I on top and bottom, you still should end up with that same result. Finally, in number 1, 1 plus 4I over 8 minus I. I'm going to multiply by the complex conjugate on top and bottom. The real part stays the same. The imaginary part is the opposite. And on bottom, I have 64. Outside, inside cancels. Minus I squared. This is really plus 1. This is something over 65. And on top, I have 8 plus I plus 32I plus 4I squared, which we know is minus 4. This is 4 plus 32I. Notice I don't leave it like that. I split it up into 4/65. I call this the butterfly effect in algebra, in case anyone's wondering. Plus 32/65 I. Okay, I know that was still fast. We're going to continue to go over this, but the homework is posted on Schoology, and you can access it through our folder in Unit 2. So I hope you have a great weekend. See you later.